Hi guys, welcome to my YouTube channel. In my today's video, I will be teaching you guys how to determine the acceleration, retardation, distance from the velocity time graph. So we have a question here. Question goes thus: a train starts from rest and accelerates uniformly at a rate of 2 meters per second square until it attains a maximum velocity in 20 seconds. It maintains this velocity for another 20 seconds and then return uniformly to rest after a further 20 seconds. So the first question says we should draw a graph of the motion. So if you want to draw a graph on the velocity time graph, we first need to write something like this. Okay, let's first copy solution. So you first need to write the vertical and the vertical line, and also you also write the horizontal line like this. So from the question, they said that a train starts from rest. This is the point of rest. This is the point of zero. So it now accelerates uniformly at the rate of 2 meters per second. This is the point of the acceleration. So we are going to copy 2 meters per second here, meter per second square. So it attains a maximum velocity for another 20 seconds. So from this point, this is the maximum velocity, this is the way it attains the maximum velocity. So we draw a perpendicular line to trace it down. So the best way for you to write it, just first write the 20 seconds inside this place so that you won't be mistaken. So you trace it back to this side. This is the point of the final velocity. This place is where our initial velocity. This place will be our final velocity. That's the maximum velocity that it attains in 20 seconds. So then I said it maintained this velocity for another 60 seconds. The velocity is maintained for another 60 seconds. We draw a perpendicular line like this also. So it maintains it for another 60 seconds. So after that, and then return uniformly to rest after a further 20 seconds. So this is the point of the retardation. We bring it down for another 20 seconds. So we have drawn the velocity time graph now. This is our velocity time graph. This is the final velocity. This is the initial velocity. This is our time here. So we have to distribute the time here now. We are going to look for a number that if we put it here, if we subtract it from a zero, it's going to give us 20. So that number is still going to be 20 seconds. So we think of a number again that if we put it here and subtract it from this 20 here, it's going to give us 60. So it's going to be 80 seconds, because if you subtract 20 from this 80, we are going to get 60. Same way, we are going to we are going to add 100 here, seconds here, because if you subtract 80 from this, it's going to give us this 20 seconds that we're talking about. So we can regard this one as our T1, this one as T2, T3, and this one will be our T4. So from the first question, they said we should draw the graph. So we have draw the velocity time graph. So the second question answer, we should use this graph to determine these three that we have here. So the first one is the maximum velocity reach. So this is the maximum velocity. This is the initial velocity where it stands from. Remember, we are given an acceleration. So for the first question, let's copy it here. We have the acceleration to be, we denote acceleration as a to be equal to velocity all over time. And from the graph, we have true velocity there. So acceleration will now be equal to v minus u upon t. And don't forget, we have T2 and the T1. So since this one is going to be zero, you can just copy only T, which is T2 here, because the time that takes this train to reach the maximum velocity here is going to be 20 seconds. So the acceleration is 2. The final velocity that the velocity we are looking for is v. This one is going to be 0, our initial velocity, upon 20. So making v as the formula, we're going to have 2 multiplied by 20, which is going to be 40 meter per second. So we have already determined our maximum velocity like that. So for the second question, they said we should find the retardation. So this is the point of retardation. This place is the point of acceleration. This is the point of retardation. This is the point of retardation. We can also call this point the acceleration. You can also call it the acceleration, or you call it the retardation. So this is the point where we have, this is the point, we call this point constant velocity. This is the point we call constant velocity. So for the second question, question 2, we got 2, we decided to calculate the retardation. Retardation, this is the point of retardation. So we still have the same formula with the normal acceleration, but its zone is going to be in negative because it's coming downward. That is retardation. So acceleration is still going to be velocity all over time. But remember, from the graph, we have two velocity. That is we have the final velocity and the initial velocity. So it's going to be v minus u upon t. Now, this is the point where the train starts. It deceleration from this point. So you trace it down to the time. So it falls to time 3. And when it's coming down again, it's fall also to time 4. To trace this line down to time 4. So it's going to be T4 minus T3. So now our deceleration, we are looking for deceleration. Our final velocity we have gotten, which is 40. So we copy it here, 40. Our initial velocity where it stopped, the final velocity here is now 0. Our final velocity here, this one is now final, it's going to be 0. So down to 100, T4 minus 80. So 40 upon 100 minus 80 will give us 20. Yes, it will give us 20. If we subtract, it's going to give us negative 2 meter per second square because it's the selection. That's why we write this negative 2. So for the last question, they said we should calculate the total distance covered. Total distance covered during the acceleration, during the constant velocity, and during the retardation. We are going to sum all the three boxes that we have here, all the two right angle and the two angle that we have here, the half angle, sorry, the two half angle that we have here, and this one we are at the center. So for my figure 3, we are going to have the velocity to be equal to total distance upon total time. So we are storing for the total distance. So let denote it as x and let denote v as velocity as v and this one as t. Because if we cross multiply, we are going to have it like this. So now the velocity that we have from our graph is 40. So let's first calculate the total distance during the acceleration. So the first thing we have to do, we are using this formula now to solve for the total distance for this third question that we have here, which is distance covered. So now let's solve for the first box that we have here, which is this one, the total distance during the acceleration. The box is half, so we are going to first copy the half. We're going to copy the half first, multiply by the velocity. Multiply by the velocity, the final velocity v. We are going to add the velocity together normally, but this point start from the 0. There is no need for us to copy it. So v multiply by t. This t2 minus t1. Since t1 is t 0, there is no need for us to copy t1. So we are going to just copy t2. Can close the bracket. So for the second one, from the second graph, this second box, the final velocity, our formula is still velocity times time. So this box here is not half. So there is no need for us to copy half again. So the velocity is going to be 40. Yes, it's still going to be 40 multiplied by, so you can open bracket for it, t3 minus t2, t3 minus t2, because we have velocity. Velocity ends here. The time for constant velocity ends at 80. So 80 minus 20, that is our t3, starting from the t2. So we have it like that. So the last one, let's do it like this. So for the last one, we are going to have, the last box is going to be half, which is the half triangle also. It's going to be half multiplied by the final velocity, which is v, which is 40, which is 40. Let me first copy v so that I'm able to understand this clearly. V multiplied by t4 minus t3. So now let's now start inputting our data now. So we are going to have half here multiply by 40, our velocity, multiply by 20, which is T2, plus 40 again, multiply by T3 is 80. So you subtract it from the 20. So we are coming back to that. So after that, plus you add it together, half, this one is half again. So V multiplied by 40, T4 is 100. So you subtract it from 80. So after we have written this, so the next thing is for us to multiply the one that we're going to multiply first, then we now add everything together. So total distance during this point here now is going to be 400. The next one here is going to be 20, that is 60, 80 minus that is 60, so it's going to be 2400. So this one is going to be 100 minus 80, 20, multiplied by this two, so this one is going to be 400. So now the total distance for everything now is going to be 3200 meter. So if you enjoying this video, please kindly drop a comment below it. If you have any question, you can drop it. I would love to hear from you guys. And don't forget to like, subscribe, and hit the bell for more study tips. So thank you.